Hello, and welcome back to my another video. Today we will learn some interesting things. Very first we will learn what is cloud computing. Then we'll see why do we need it. Then how tech giant Amazon Web Services helps us. Then we'll see why and how do we reduce latency. And as always a quick practical. The practical will be interesting if you are a software engineer. So let us first understand what is cloud computing and its need. For understanding this I will play a very short video of Amazon itself. Here we go.
Cloud computing is the on-demand delivery of IT resources via the internet, with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like Amazon Web Services. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases, such as data backup, disaster recovery, email, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. For example, healthcare companies are using the cloud to develop more personalized treatments for patients. Financial services companies are using the cloud to power real-time fraud detection and prevention. And video game makers are using the cloud to deliver online games to millions of players around the world. With cloud computing, your business can become more agile, reduce costs, instantly scale, and deploy globally in minutes. Cloud computing gives you instant access to a broad range of technologies so you can innovate faster and build nearly anything you can imagine. From infrastructure services such as compute, storage, and databases, to Internet of Things, machine learning, data analytics, and much more. You can deploy technology services in a matter of minutes and get from idea to implementation several orders of magnitude faster than before. This gives you the freedom to experiment and test new ideas to differentiate customer experiences and transform your business, such as adding machine learning and intelligence to your applications in order to personalize experiences for your customers and improve their engagement. You don't need to make large upfront investments in hardware and overpay for capacity you don't use. Instead, you can trade capital expense for variable expense and only pay for IT as you consume it. With cloud computing, you access resources from the cloud in real time, as they're needed. You can scale these resources up and down to grow or shrink capacity instantly as your business needs change. Cloud computing also makes it easy to expand to new regions and deploy globally in minutes. For example, Amazon Web Services has infrastructure all over the world, so you're able to deploy your application in multiple physical locations in just a few clicks. Putting applications in closer proximity to end users reduces latency and improves their experience. No matter your location, size, or industry, the cloud frees you from managing infrastructure and data centers so you can focus on what matters most to your business.
Wow! That was a nice video by Amazon. Now let us continue with our next part. So what are the types of cloud computing? The very first is on-premises, infrastructure as a service, platform as a service, software as a service. Note, the blue colored are which we manage and the orange one are which service providers manage for us. Let us now see their examples to understand them in more detail. Software as a service. Its examples are Google Apps, which most of us use, Dropbox as a cloud storage, Cisco Webex we use for a live streaming, so these all are which client can directly use. Now platform as a service. Examples are OpenShift by Red Hat, REPL.it. You might not know REPL.it. So let's see what is it. Just go to Google and search for REPL.it, you will get this website. Watch what I do. This website behind the scene used container technology. When we press create REPL, it goes and installs a new ready-made operating system for us. And then we can use it as a platform for managing all our work. This is a very basic Hello World program of Python. Now infrastructure as a service. Its example is Amazon Web Service, we also call it as AWS, Microsoft Azure, Google Compute Engine, GCE, Google Cloud Platform. It is also a cloud provider like AWS. Now let us see how Amazon helps us by providing us infrastructure. Its key use is that we can deploy our web applications on cloud and anyone on the globe can use it. Amazon EC2. Its full form is Elastic Compute Cloud. It is a service that provides secure, resizable compute capacity in the cloud. You can consider it as your laptop, but on some remote location. It provides you with complete control of your computing resources and lets you run on Amazon's proven computing environment. Let's see what maximum resources it can provide us remotely. Its another key benefit is that we need to pay very less for high resources. They charge us hourly basis, which is always cheaper than having such high configuration set up at our location. It is a reliable, scalable infrastructure on demand. It allows us to increase or decrease capacity within minutes. Now I have logged in. And after knowing its maximum configuration setup, you will be surprised. We can have any operating system, like Ubuntu, Red Hat, Windows. Even Amazon have its own Linux. Note: AWS provides some services free for some hours, so it is written free tier. Have a look, here only T2 micro type of setup is free for some hours. This column shows CPU count of the system. This column shows memory, we also call it as RAM. This column shows its hard disk. There are configurations for network performance and many more. Now let us find the maximum configuration available. For the same, let us sort columns by descending order. Just amazing. Here you can see the count is 128 CPU, just imagine the performance. Let us see memory, that is RAM. Wow. One can have maximum of 4000 GB of RAM, almost 4 terabytes of RAM. $60 terabyte of hard disk. And you can sort whatever you want. Let's continue to the next part. Now consider that you have some business and for providing service to your clients, you have your website which is used by number of clients, let's say it is Instagram. So on Instagram you have lots of static and dynamic data. Static data can be images, videos. And dynamic can be Instagram's web application. It is updated to fix bugs by developers and so code updates regularly. In such case, where you have too much of static data, here we have images in our case. So we store these images in a persistent storages, persistent here means permanent storage. So AWS provides the service named S3, which can be on any of the availability zones of AWS, say our state's capital in this diagram. Let me first show you availability zones of AWS. For that I will go to their website. Availability zones simply means that AWS have physical hardwares on these locations. Here blue dot means that they are in service. You can have a look on the screen. The orange dots shows that they are coming soon. On blue dot, it also shows the year from which the service was made available. You can have a look on the screen. Let's continue to the next part. Let us again come to our example of Instagram. Consider we have 70% of clients from India and only 5% of clients from California. The current infrastructure we have is like, we have S3 storage, which is a persistent storage, is in India's availability zone. Let's continue to the next part. And therefore whenever a client of California sends a request for any image, the image is transferred from India to California. And therefore the latency increases. Similarly, some of our customers can be spread all over the world, but as maximum clients are from India, we configured S3 in India. If we configured S3 in all availability zone, it will cost us a lot. So here CDN content, delivery, network comes in play. Let us understand it. The diagram shows with CDN and without CDN. Without CDN, when a client sends a request to S3 storage, it responses the data. But when multiple clients do same for a particular data or say image, it again and again sends requests and response. So in CDN, whenever a first client sends a request for an image, say named image.jpg, it creates a local copy on the nearest location of client. So, though the first client faced latency, remaining clients requesting for same data won't have any latency. And low latency can be obtained in low cost. Now the question is, how Amazon Web Service helps us with CDN. The service here in AWS is called as CloudFront. Consider the map, here these dots represents edge locations, it is nothing but small data centers across the world so that maximum area across the world can get high quality of service. Consider some clients are from California and some news is trending in India, so multiple clients will request some particular set of images or videos, so here CloudFront will create its local copy in the nearest edge location and can easily access it with very low latency. Let us slowly move towards practical implementation, for that we should know how to configure it. This diagram shows the exact working architecture of CloudFront, where first client will go to CloudFront on its nearest edge location. If required data is available, it will quickly retrieve the data, else the local copy will be created and maintained in edge location for some days, as per the requirement. Now comes the steps of configuration of CloudFront. First, the developer will configure web server, then will create S3 bucket and will mount S3 bucket and web server. In second step, developer will upload all the static data in S3 bucket. In third step, CloudFront will be configured in each of its edge location. Then the CloudFront will send its identity to developer and all its edges logs. Now we will do its implementation. But for implementing there are multiple ways, let's discuss the two best ways. One is manually and another is using Terraform. But as we are in automation world we will go with Terraform. Terraform is a tool where we can manage multiple infrastructures with one click. You can pause and read if you want more information about Terraform. So now we are just managing AWS right now. Let's implement it. On desktop I have a folder and another folder in that. This folder have two files. One is Terraform code and another is images folder. I will upload these all images on S3 and configure CloudFront for my website's static data, which here is this images folder. This is my Terraform code which will configure a complete infrastructure as we discussed till now. Though it looks of 350 lines, but it is very easy. I have my website's programs on GitHub. The Terraform code will download all the programs from GitHub and will configure Apache web server on EC2 instance as discussed earlier. These are the website's program on GitHub. Now I will quickly open command prompt and will go in the folder where my Terraform program is kept. Now I will show you that there is no infrastructure set in my AWS account. Have a look, there is nothing here. Even S3 bucket is empty. Here I will first download all the plugins required by my program. These plugins are downloaded automatically. Now I will do Terraform apply to execute my program and it will start building infrastructure as you can see. Now my infrastructure is ready. After building the infrastructure my program will generate a text file and we can find the IP address where our website have been hosted. Have a look to the website, it is a simple e-commerce website. Here these all images have came from CloudFront's configuration. As our complete infrastructure is ready you can see the counts of services have increased as I am using one resource of some of the services. These are S3 images. Now I will destroy the complete infrastructure in one click. This will terminate all my in-use services for the current infrastructure. You can see the AWS account status. Even our website is down. Now I will create the complete infrastructure again. Note the new generated IP address. I will share same with you and will keep this infrastructure active till today noon 12 p.m. Do visit the website and report me if it goes down or if you faced latency. Note: today's date is 21st June, 2020. Thank you.